Welcome to MRU E-Learning powered by Malla Reddy University. Myself, Mr. G. Apparao, Assistant Professor of AML Department, School of Engineering, Malla Reddy University. So today, I'm going to explore on schema refinement in normalization, that is in the DBMS, that is also called as normalization. So let's get into the details. So the contents of this presentation is normalization. First, we'll be discussing about normalization. That means what is normalization? Functional dependencies. What is functional dependency and what are the different types of functional dependencies are there and how it is related to normalization. And then we'll go to first normal form, second normal form, third normal form and Boyce normal form. There are some more normal forms there, but at present, since for any application that frequently uses these four normal forms, we'll be discussing about these four normal forms only in today's class. Okay, moving to normalization. What is normalization? So we'll discuss the first four normal form as I mentioned earlier. So first, normalization is the process of improving database design, which is apt to the underlying applications. And the ultimate goal of normalization is to reduce or to completely eliminate the redundancy. If there is redundancy, there will be a problem with the accessing of data and retrieval of data and any operations that are need to be performed in DBMS. So now, so as part of that, so we'll be seeing first normal form is considered as the weakest one, and second normal form the stronger than first normal form, 3NF stronger than 2NF, and then finally BCNF, which is considered the strongest among four normal forms. Now, if any relation which is in BCNF, then it is obviously it will be in 3NF. Any relation that is in 3NF, that is said to be in 2NF, and then any relation that is in 2NF is said to be in first normal form, because we will achieve the normal forms one by one. So by using this picture, we can understand how these are achieved in an order. So first, on a relation, we can achieve first normal form, then second normal form, then third normal form, then BCNF, 4NF, 5NF are also there. But at present, we are not discussing these fourth normal form and fifth normal form. We are going to discuss about the first four normal forms. Now, coming to normalization, so we consider a relation in BCNF to be fully normalized. If a relation is in BCNF, then we can say that that relation is fully normalized. Even though fourth normal form, fifth normal forms are there, they are used for specialized purposes. Now, the benefit of higher normal forms is that it is used to update semantics for the affected data are simplified. So we can easily simplify the affected data. So that is subject to some application. So this means applications are required to maintain the database in a simpler manner. So hence we can, if we achieve more normalized data is more simpler to handle by any underlying application. So a design that has lower normal form than another design that has more redundancy. So as I told you, the main objective of normalization is to reduce the redundancy or to completely eliminate the redundancy. Now, as part of that, so if lower normalization, which result in less feasibility to handle the data, and higher normalization will result in higher feasibility of handling the data. So redundancy is reduced. Automatically, it will be easy for us to handle the data which is under some underlying application. So first we introduce the concept of functional dependency. So why functional dependency? So functional dependency is clearly understood, then it is easy for us to understand, to relate with the normalization, because the concept of keys in DBMS is relied on functional dependencies. So what is functional dependency? Now, functional dependency is something we say an attribute B, that is RHS, which is in RHS. B is said to be functionally dependent on another attribute A. We say this when a tuple that is there in A, if it is resulting in some value in B, in the another tuple, in a different tuple also, if it results for same value for that value, for the corresponding value in A, then we can say that B is functionally dependent on A, or else we can say A determines B. Let us understand, try to understand little clearly. Now, let's see an example here how functional dependencies will be working. So, just I'm taking an example relation here, that is an employee relation. Now, in the employee relation, we have employee number, employee email, employee first name and last name. Now, employee number determines employee email. So now as the employee number is unique, it can be used to determine another attribute, another corresponding attribute, employee email, employee first name, employee last name. So likewise, now the attributes employee email, employee first name, employee last name are functionally dependent on key attribute, that is employee number. Okay, so this is, hence we can say, now if you say employee number is A, now any other attribute that is determined by A, say it is B, then we can say that A determines B. So by this example, we can understand what is a functional dependency in a simpler manner. Still more, if we explain more, so the functional dependency can be depicted in different ways. So first, the determinant way of expressing, same, employee number determines email, F name, last name as well. So this is another way of representing, and in some textbooks or in some text we can express like this also. We can depict the functional dependency like this also. Employee number functionally determines on employee email, employee F name, employee last name. So like this, we can depict functional dependency in different ways. Now, what is determinant? So, what is there in LHS? What is there in LHS is the key attribute, and what is there in the RHS is called as a dependent. Now, the determinant, so employee number is the determinant of employee email. Now, we read it as employee number determines employee email, is functionally dependent on employee number. So, either of the ways we can say that. Now, coming to dependencies, there are different functional dependencies mentioned. Normalization, which are related to normalizations, that is partial dependency, and one more dependency is transitive dependency. These are the two dependencies, even though there are some other dependencies. These two are related to the normal forms, which we are going to discuss. Now, coming to partial dependency. What is partial dependency? Suppose if you take a table here, name, that is inventory. So, inventory table we are taking. So, here in this table, the attributes are inventory number, line number, quantity, and inventory date. Now, the inventory number and the line number, these two attributes together forming the key. So, there is a concept called key, which is very crucial in DBMS. So, in that, candidate key is unique key that is used to identify each row uniquely in the table. Now, inventory number and inventory line number both together forming the candidate key. Now, if these two are forming the candidate key, from the candidate key, we are able to determine the values of quantity and inventory date. That means now quantity and inventory date both are functionally dependent on inventory number and line number. Okay. So now what are the candidate keys of this table? Inventory number and line number. Now inventory date is partially dependent on inventory number and line number. How can we say this? So this can be said based on like being inventory number and a line number. So inventory number is, suppose say these attributes are A, B, C, D. Now A and B together called candidate key. Now being candidate key, A and B candidate keys, they are determining C and D as well. Now what is partial dependency is being part of the candidate key. If any one of these attributes, called, they are called as prime attributes. One more thing we have to know here is the attributes which are part of candidate key, that is, which are used to identify each row uniquely, are also called as prime attributes. The other attributes are called non-prime attributes. Again, I'm repeating, the attributes which are part of candidate key are called as prime attributes, which are out of that candidate key, that is, those are called as non-prime attributes. Being candidate key, which determines all other attributes, that is non-key attributes in the table, if any one of the attribute which is subset of the candidate key is determining any other attribute, any other non-key attribute, means then we say that there exists partial dependency. Now here in our example, inventory number is determinant of inventory data. Inventory number is the determinant of inventory date. That means inventory number is partially determining inventory date. That means inventory date is partially dependent on inventory number. So we say that there exists the partial dependency here. I hope it is clear. Such dependency, that is inventory number determining inventory date or line number determining inventory date, that kind of dependency need to be removed from this table. Okay. So if we remove this table, then it will be prompted to the next normal form. We'll see. We'll get to know about that. What transformation the table is going to take place. Second kind of dependency we thought of discussing is transitive dependency. Now, what is transitive dependency? We can understand by using this example. Here, we are taking again employee table example. Employee number, employee email, department number and department name. Now, here in this, employee number is the candidate key. So, employee number is the candidate key, that is key attribute. Being employee number determining all other attributes, that is employee email, department number, department name. And department number separately, if you observe, it is separately determining the department name. Now, if this kind of dependencies occur, what can we say? Suppose if employee number is A and all other attributes are B, C, D. Now how can we mention this dependency as A determines B, C, D, B, C, D. Now, in addition to that, what are the other dependency that is occurring here? C determines D also. Now, we can say transitive dependency in a simpler manner that A determines already A determines C. A determines C according to the dependency given. A determines C and C separately determines D again. That means A determines D. This is called transitive dependency. Hence, in this relation, transitive dependency occurs. So, transitive dependency, whenever transitive dependency occurs, again somewhat duplicacy is involved here. So, department name is transitively dependent on employee number via department number, where we can say employment number determines department name. So, A determines C, C determines D, hence we can say A determines D. As A is directly determining D, what is the need for C to determine separately? So, this kind of dependency need to be eliminated. Okay, so this is called transitive dependency. Now, going back, so partial dependency, if we remove partial dependency, then the table is going to be converted into one form. If we remove transitive dependency, it is going to transform into another form, that is another normal form. So, which way we are going to see how these dependencies are related to normal forms. First, let us see first normal form. In the first normal form, what is the basic requirement? We say a table or a relation is in first normal form if all values that are stored in the relation are single valued and atomic. Okay. So, now we can say that a table is in first normal form if this restriction is followed. What is that? All the values should be single valued and as well as they should be atomic. What does it mean? That means we can understand that by using this table. Let's see, for example, we have employee table here. So, employee number, employee phone and employee degree we are giving. Of course, we have an empty cell where the values are not provided, even though we can use this example for explaining first normal form. Now, coming to the employee degree, one can have many degrees, multiple degrees. In that case, when we write tables manually, we can write like this. But when we enter these values into database management system, it will not allow us to enter the values separated by comma. Now, that means what? If we enter this kind of values, that is employee degree, BA, BSc, PhD, it should not be allowed in the DBMS. That means every relation that we enter in the DBMS, any database management system, is to be by default in first normal form. So, it should be in first normal form. Now, for converting this table into first normal form, what we need to do? So, the degrees whatever we have, those values should be given in a singular manner, not separated by comma. Any database management system does not allow you to enter the values like this. So, in such cases, we have to convert the table into first normal form. So, how do we do so? Now, so what we can do? So, by taking this table, okay, so if we decompose them, so the basic idea of normalization is to convert some larger, suppose A is the parent table. Now, in order to remove the redundancy or eliminate the redundancy, we are decomposing largest tables into smaller tables. So, a larger table A can be converted into or decomposed into smaller tables B and C, so that it will be transformed to another normal form. So, in order to follow the first normal form or in order to achieve the first normal form, what we need to do is, now the employee table is divided into two smaller tables, employee and employee degree. Now, employee table is consisting of employee number and his phone, and employee degree is having employee number and employee degree. Now, what we can do, if you see, according to the previous table, employee number, employee phone number, they are having atomic values, single valued attributes. The problem is with the employee degree only. Now, employee degree can be separated in another table with reference of employee number. So, employee who is having employee number 333 is having multiple degrees. That means 333 has to appear multiple times. So, 333 has to appear multiple times in the table. Okay. So, instead of having them separate, having them mentioned separated by comma, so what we are doing here is we are keeping them into different rows, different records. So, hence all the rows in this table are having single valued attributes. In the table employee also, we are already having single valued attributes. Hence, table employee and employee degree both are into first normal form. This is how we will achieve first normal form. Coming to the second normal form. So, how do we go with the second normal form? So, second normal form has a restriction that every non-key attribute is fully dependent on each candidate key. Now, here we have to get more clarity on candidate key. What is candidate key? Now, simply the concept is very simple. Key is any attribute, single attribute or a set of attributes which are used to identify each row uniquely. Now, what is super key? Super key is the one same group of attributes or a single attribute that is used to identify each row uniquely. Now, minimal set of super key is called as candidate key. What is candidate key? Minimal set of super key. That means minimum number of attributes that are required or subsetted from super key which are used to each row uniquely in the table, in the relation. Now, the candidate key, what we are saying for the second normal form, what is the requirement? A relation is in 2NF if it is in first normal form, the first primary condition, because as we discussed in the diagram, in order to achieve some higher normal form, first by default it should achieve the lower normal form. So, for you to be in second normal form, for a relation to be in second normal form, first we need to achieve the 1NF. So, if 1NF is already there, if a relation is already achieved first normal form, then we can go with the second normal form. So, second normal form requirement is every non-key attribute is fully dependent on each candidate key. So, here we can remember what we talked about partial dependency. If any non-key attribute completely depend on primary key alone for its dependency, then it is fully functional dependent. Now, if any part of CK, that is part of candidate key, okay, if candidate key is available, part of CK means any prime attribute, Suppose if a candidate key is having two attributes, now, so suppose AB is a candidate key, in a relation AB is a candidate key, A comma B, now B is prime attribute, A is also prime attribute. Now, we can also say that A is a part of candidate key and B also part of candidate key. Now, if any non-key attribute depending on any of these prime attributes, for example, relation R is having A comma B comma C comma D, these are the four attributes. Now, AB are the key attributes, that is part of CK, candidate key. Then if okay, so R is a relation, A, B, C, D are the attributes in that. Now, AB is the candidate key which determines C comma D. Now, in addition to this dependency, if B is separately determining C or B is separately determining D or A is separately determining C or A is separately determining D, this kind of dependencies lead to partial dependency. Now, this kind of dependencies need to be eliminated. If you eliminate partial dependency from the table, then automatically it will be converted into second normal form. I hope it is clear. So the second normal form demands that the relation to be in first normal form first, then any non-key attribute to be fully dependent on each candidate key. So that kind of requirement is enough for converting a relation into second normal form. Now, next normal form that we are going to discuss about is the third normal form. So, of course, sorry. For second normal form, let's see an example just to understand little clearly. So, again, we are taking the example of inventory table, inventory number, inventory line number, product number, quantity, inventory date. We are having these are as attributes. Now, in this table, candidate key, that is part of candidate key are inventory number and line number. Now, these two attributes are said to be prime attributes. Now, there are dependencies defined here. Inventory number, line number together determines product number and quantity. And coming to inventory number, inventory date also it determines like inventory number and line number together determines inventory date as well. Okay. Along with that, we have another additional dependency, that is inventory number determines inventory date. For suppose, if inventory number separately determining inventory date, then automatically the partial dependencies occurred. So now, in order to eliminate this, what we are going to do is converting them into smaller tables, that is decomposing them into smaller tables. Now, what we are doing is, as inventory number separately determining inventory date, we will keep those two attributes in a separate table and remaining all other attributes in a different table. So, hence what happened? Now, this is the candidate key. Candidate key determines candidate key, that is candidate key means inventory number and the line number together determining product number as well as quantity, and inventory number separately determines inventory date. Since we have separated this partial dependency into a different table, there is no problem with our partial dependency. Hence, the partial dependency is removed from the relation inventory. Okay. So, hence, we have achieved the second normal form. Coming to the another example, so just for your guessing. So, is the following relation is in 2NF, that is inventory number, line number, product description and quantity. So, these are the attributes of another table. Now, if you see what are the dependencies mentioned here. So, inventory number and line number, these two are candidate keys, part of candidate key. That means these two are prime attributes. These two together determining product number, product description and quantity. So, we don't have any problem with this type of dependency. Where we have problem? The problem that we have here is, again, product number is separately determining product description. If you give product number, we can describe the product. So, such dependencies occurred here. In such cases, what we have to do? So, here we can say a non-key attribute, product number being a non-key, it is determining another non-key. A non-key determines another non-key. So, in this type of cases, what we can say? Can we say this is in second normal form? Of course, yes. So, it is in second normal form, but it is not in third normal form. So, for that, what we have to do? For converting a table into third normal form, what we have to do? We will see in the next normal form. So, 2NF but not in 3NF nor in BCNF as well. So, if 3NF itself is unable to achieve, automatically BCNF is not achieved. So here what we will do, so we will go with this example, sorry. Now here at this step we are going to spend some more time on to understand what is 3NF and BCNF. Now once a table is or a relation is converted into 2NF, for converting the table into 3NF, what is the additional requirement? What are the additional requirement that is required? Suppose if X is an attribute or a set of attributes, Y is another set of attributes. Now we say X determines Y is the dependency, functional dependency, X determines Y. For a relation to be in third normal form, every LHS of the functional dependency, either it should be a prime attribute, Y should be a prime attribute, or X should be a super key. X should be a super key, or the RHS should be a prime attribute. Prime attribute means, already I told you what is a prime attribute. Prime attribute is the one which is part of candidate key. Now the RHS, whatever is there, it should be a prime attribute, or X should be a super key, so that automatically if you achieve this necessary and sufficient condition, what happens is automatically transitive dependencies are removed. Transitive dependencies are removed. Already we discussed what is transitive dependency. That is, A determines B and B determines C. Then we say that A determines C is the transitive dependency. Being primary key, if being a candidate key, if candidate key is determining all other attributes, there is no need of intermediate attribute that is determining another attribute. So that kind of transitive dependencies need to be eliminated from the from the table, so that it will be converted into 3NF. That table will be converted into 3NF. So that can be achieved by achieving this rule, that is LHS should be a super key or RHS is a prime attribute. Okay, that is third normal form. And coming to the BCNF, BCNF is the last normal form that we want to discuss about. So the BCNF can be achieved. BCNF can be achieved by little bit modification in the third normal form. For any functional dependency, X determines Y if X is super key only. Okay, always X, what is there in LHS should be a super key. Then only we can say that it is the BCNF, Boyce coord normal form. Okay, so this normal form is named after Boyce and coord, who are the EF coord. So his name is EF coord. We also call him as father of relational database management system. So this normal form is named after another, along with EF coord, another scientist called Boyce. So these two together developed this normal form. Hence, it is named as Boyce coord normal form. So the basic requirement of Boyce coord normal form is to make LHS as a super key. So in order to do that, we have to transform the table in such a way that no non-key determines another non-key. So in order to get that, so non-key determines non-key kind of things need to be removed. So that, in this example, what we can do is, if SSN is the key attribute determining all other attributes, so SSN with up to D number we can keep in one table, and SSN along with the department name, department number determining department name, we can keep it in another table. So these two decomposed tables will give you the BCNF. Hence, all normal forms up to BCNF are achieved. So we have discussed once we have a recap of what we have discussed. We discussed what is a normal form, let me come back to the contents. So we have discussed normalization, functional dependencies, first normal form, second normal form, 3NF, BCNF. So I hope the concept of normalization in DBMS is clear to you. Thank you.